Lab 1. Charge tapes. The purpose of this lab is to see when a tape is pulled apart from another tape, the tape can acquire an excess of charge. Then we're going to approximate the amount of charge on the floating tape. Through this experiment, we're going to become familiar with the idea of charge and design experiments with everyday household objects like tape. We expect the outcome to be two U-tapes repelling each other and amount of excess charge on a tape that's between 1.6 times 10 to the negative 19 coulombs and 1 times 10 to the 5th coulombs. We're going to discuss the physics principles, experiment methods, calculations, computational model, and challenge questions. The fundamental physics principle discussed in this experiment is that like charges repel and opposite charges attract, and the idea of electric field, and we can calculate the magnitude of force due to electric field using the formula 1/4 pi epsilon times q squared over distance squared. And lastly, we can calculate the force due to gravity using mass times gravitational acceleration. So these are the U-tape interactions that I've experimented with, and when U-tape is placed close to hand, it attracts. And when it's placed close to neutral objects like a book, it still slightly attracts. And when it was placed close to a negatively charged plastic pen, it still attracted. And lastly, when a U-tape was placed close to another U-tape, it repelled because they have same charges, and so same charges repel. From this, we can say the U-tape is positively charged because it attracts to negatively charged plastic pen. In the experiment, the length of the tape was 0.2 meters and the mass was 2 times 10 to the negative 4 kilograms. The distance between two tapes when one began to float was r equals to 0.03 meters. As you can see on the right, there's a diagram. The magnitude of gravitational force was 1.96 times 10 to the negative 3 newtons, and the magnitude of electric force on tape B should be equal to the magnitude of gravitational force because the momentum of tape B is not changing, thus the net y component of the force on tape B is 0. Through calculations, as you can see on this slide, we calculated the charge on one tape to be 1.4 times 10 to the negative 8 coulombs. And then, using dimensional analysis, I was able to calculate the number of electrons that are deficient, which is 8.75 times 10 to the 10th electrons. Next, the ratio of the number of deficient electrons to the number of atoms on the sticky surface was calculated using this ratio equation, and we got 2.19 times 10 to the negative 7 to 1, which is the number of electrons per one atom that are deficient. Then next, just to highlight the key functions on my GlowScript code, I've used f sub g equals mg times vector 0, negative 1, 0, so that it's going to have a gravitational force pointing downwards. And I've set the electric force equal to negative Fg, which is the same magnitude as gravitational force in the opposite direction. And I've rearranged the equation for electric force to calculate the Q, which is charge on one tape, which is equal to be square root of magnitude Fg times the distance between two tapes squared divided by the constant 9 times 10 to the 9th. By looking at the computational model using GlowScript, we were able to create a visual model of the forces acting on two tapes. As you can see, the blue arrow represents electrical force, and the orange arrow represents gravitational force, and the green arrow represents the hand force. And through the calculation on my GlowScript code, I was able to figure out that the charge was 1.4 times 10 to the negative 8 coulombs, which is equal to the previous slide that we mentioned before. We assumed in this experiment that we ignore air resistance on tape A and treat the tape as point charges, and both tapes have the same amount of charge evenly distributed. What if electrons had positive charge and protons had negative charge? The U-tape will have excess negative charge because it has deficiency of electrons, and the tape will repel from the negatively charged plastic pen but still attracts to neutral objects due to polarization. It's important to handle the charged tapes as little as possible because whenever the charged tapes come into contact with my hand, electrons transfer from my hand to the tape to balance the excess positive charge on the tape and to reach equilibrium. Lastly, to conclude, there is excess positive charge on a 0.2 meters length of tape, which is equal to 1.4 times 10 to the negative 8 coulombs, and this is within the range of 1.6 times 10 to the negative 19 coulombs and 1 times 10 to the fifth that we expected at the beginning. This means there's a deficiency of 8 times 75 times 10 to the 10th electrons on each tape.